In this lesson, we're looking at some of the benefits and risks of radioactivity. Our lesson objective: explain the benefits and risks of using radioactive substances and reactions. So we already did some work with half-lives, and so carbon-14 is one of the examples that we used, and it's used to date organic material. Since organic material contains carbon, if we find some organic remains, such as some bones, for example, what we can do is look at the ratio of the radioactive carbon-14 that's in the substance and what it beta decays to over time, which is nitrogen-14. So looking at that ratio of carbon-14 to nitrogen-14, and knowing the half-life of carbon-14, which is just over 5,700 years, we can then date this organic material. Now, the half-life is not long enough or useful enough to help us date things like rock formations or even the age of the Earth, and so we want something with much longer half-life, and so that's why we typically use uranium to date rocks and to date the Earth. We could also use radiation to help us kill bacteria and mold on our food sources. And if we venture into our house and we look at our smoke detector, inside the smoke detector we do have a radioactive source, which is AM-241. Don't be concerned, it is encased in a chamber, so there's nothing to worry about in terms of any radiation that's leaking out. But AM-241 has a nice long half-life, and so this is going to outlive the length of your battery. And the way it works is pretty simple. The americium radioactive source is going to emit alpha particles, and these alpha particles then will allow for the conduction of electricity across these metal plates. And when there is smoke in the room, the smoke is going to interfere with those alpha particles, and it's going to stop the flow of current across these plates and set off the alarm. We also use things like carbon-14 and phosphorus-32 as tracers. So, for example, if we're looking at plants, we can look at the uptake of carbon-14 into the plant. Phosphorus-32 is actually used to look at the uptake of fertilizers up through the plant into the leaves. And we can trace that pathway using these tracers. Iodine-131 is used to treat overactive thyroid disorders such as hyperthyroidism. And typically when we are using some sort of radioactive substance in the body, we want to make sure that it has a very short half-life. And this way it decays fast enough that it gets out of the body rather quickly. And so for iodine-131, the half-life is just over 8 days. Some other uses of radioactivity: cobalt-60 is used to treat cancer, and TC-99 is used to detect tumors. So let's check your understanding. Can you identify species used? Now let's look at some of the risks of radioactivity. It can lead to damage of our tissues. It can cause mutations of our genes. It can lead to pollution due to radioactive waste, as well as accidents from nuclear reactors, such as the Chernobyl accident. The other challenge is, what do we do with all this radioactive waste? It must be stored. So what we do is we place it in lead boxes and store it underground in these sites throughout the country. And one such site is the Yucca Mountain, which is located in Nevada. And this is a large long-term storage facility for this spent nuclear waste as well as nuclear testing. The Love Canal is just one example of what can go wrong. And so this is located in Canada. It happened in the late 1970s. And what happened was there was a leakage of some of these lead boxes containing radioactive waste into the waterways and the surrounding environment of this town. And it led to widespread birth defects and nervous system disorders. We did have a partial meltdown here in the United States. This is in 3 Mile Island, Pennsylvania in 1979. Although no deaths or injuries were reported, there was a release of some radioactive material, and we did see a spike in cancer rates and infant mortality rates in the surrounding environment afterwards. And of course, we have Chernobyl, which is the worst meltdown in history. This happened in Ukraine in 1986, and the resulting explosion led to nuclear fallout, and they had to evacuate the surrounding areas, and many of those areas are still uninhabitable today. And the most recent is the Fukushima nuclear power plant. As a result of an earthquake and the subsequent tsunami, the Fukushima power plant was compromised and did leak out some radiation. And that radiation, as we said, can impact genes, not only for just humans, but also for plants as well, as you can see here. And lastly, we use radiation for, or nuclear power for warfare, and we know the devastation that that can cause just by looking at Hiroshima and Nagasaki. The fusion bomb has only been tested and has never been used on any civilians. Since 1961, a ban on testing bombs has been enforced. However, the U.S. still holds over 4,000 nuclear weapons, Russia 6,000, and other nations at 200 or less. So let's check your understanding. Can you explain the benefits and risks of using radioactive substances and reactions? At this point, you should be able to identify the risks and benefits of radioactivity.